Thanks, SOSV. I'm really excited to be here today. I'm with David Keith, professor of geophysical science at the University of Chicago and the founding faculty director of its Climate Systems Engineering Initiative. We are here today to talk about carbon capture technologies and the role they currently play and the role that they could play in the future. Very relevant to that conversation, it's important that I mention that in 2009, David founded a carbon capture technology company, Carbon Engineering, which the oil and gas company Occidental bought for $1.1 billion in 2023. David, thanks for being here with me.
Thanks a lot. Excited to be here.
So, just as a starting point, let's sort of set the table. The most recent IPCC report, which is the Intergovernmental Panel on Climate Change, a global body of scientists who put together an assessment report, they said in their most recent sixth assessment report that that it will be unavoidable to deploy carbon dioxide removal for particularly hard to abate sectors. So it's just helpful to have that context of where sort of the global conversation is. Specifically, they said in order to reach net zero CO2 or net zero greenhouse gas emissions will require deep and rapid reductions in gross emissions and the deployment of CDR, carbon dioxide removal, to fill everyone in on the jargon, to counterbalance hard to abate residual emissions. And the examples they gave were agriculture, aviation, shipping, industrial processes, and they said that's unavoidable, and that was with high confidence. So helpful context there. And also relevant for this conversation, in the first half of 2025, venture capital firms put almost $5 billion into carbon capture technologies as of 2020. 4.8 billion, that's according to data from Sightline. And so far, the lion's share of that funding has gone into direct air capture, which we're going to address momentarily in case you're not clear about all the different kinds of carbon removal. So first things first, there are two broad categories of carbon removal technologies. We can sort of subdivide this sector in different ways, but I think the first categorization that's important to make is permanent and non-permanent, which is relatively obvious, but David, maybe you can just give us a brief sense of why that's relevant in this sector.
Happy to, but first I just want to comment on this IPCC stuff you started with. I think it's important to say that the claims about very rapid deployment or the necessity of rapid deployment of carbon removal are predicated on assumptions about meeting Paris 1.5 or 2 goals, and also on assumptions that no use is made of sunlight reflection, the other way the world could be cooled. So those are unavoidable under some key assumptions that may or may not be true or make political sense. And also, I think it's important to say you've said carbon capture and you mentioned carbon capture VC firms. I don't know where that data came from, but remember, carbon capture, at least as I use it, many people do, is capture from fixed sources like cement plants or whatever. And I think the topic here is carbon removal, and there's some overlap between the two in technologies, but I think they do distinct things. So jumping into carbon removal, I think the first category are basically methods that increase the amount of standing biological material, trees and soils, which means there's more carbon stored. And this is something that is in principle pretty easy to do. You do it by growing forests or changing farming practices to make more carbon in the soil. And the benefit is it's cheap, and that foresters or farmers can respond quickly to economic incentives. The challenge is it's inherently not permanent. The flow of carbon into biological systems, it also flows out, and it does that quite quickly. And so I think the way to think about this really is more than like carbon banking than carbon removal. But carbon banking is worth something. I mean, if I had a technology that had no environmental impact and no cost, and it took a ton of CO2 out of the air and it was going to release that ton 20 years later, that has some value to climate policy. And so I think we shouldn't assume that things that are not permanent are not valuable. Some of them could be quite valuable. I think there are deep challenges in accounting here that will not go away. And I think what's crucial in my view is that we don't fool ourselves by thinking that these biological methods constitute permanent carbon removal, which they don't. And maybe one other last fact that I think is important. The influence of all this biology, all the change, incredible changes in land cover in the last 150 years where forests have been cut down and regrown and so on. I think it's important probably for listeners to know a fact. Some of what I'm going to say is controversial, but this is just a plain fact. If you look at the change in the atmospheric carbon burden since 1850, and you ask what fraction of it is due to coal, gas, oil, and cement, the long lived fossil fuel emissions, compared to all these biological changes, the effect of all these biological changes is just a few percent on the accumulated carbon emissions, accumulated atmospheric carbon. So that gives you a sense that there's just not a very big lever.
Okay. Thank you very much for putting the context about the IPCC comments. That's very helpful, and I should have made that clear.
No.
But yeah, no, that is. I'm glad you mentioned that, and it's good to talk. I like how you talk about this sort of not the biologic or not permanent methods as carbon banking. That's a helpful framework for I that makes sense to me. Um, so and also, I just in terms of the biologic processes, it might be helpful also to mention that there are ocean-based biologic methods, right? It is That's also sort of part of this non-permanent category.
Yes, that's right. And I think probably
What
not
would
a
those
very
be?
important point. So it's possible to add iron to the ocean or to add macronutrients like nitrogen fertilizer to the ocean or phosphates that would increase biological activity. But at least for some of those things, say for iron, there's a very clear kind of rob Peter to pay Paul. So if you grow more oceanic biomass in one place, that depletes those other macronutrients. And when that water upwells again, then there's less biological activity. So that also turns out to be something that looks a bit like carbon banking. It may or may not be useful. I'm a little skeptical, but there's really thoughtful people working on it. But I think it's clear that it's not permanent carbon removal.
Okay. Okay. So now let's move into the permanent carbon removal. And there's a couple of categories there. First, maybe broad, big picture, why is permanent carbon removal relevant in this context? And then, maybe you can give us a brief overview of the sort of the two buckets under that hold, the different kinds of permanent carbon removal. So we have enhanced weathering, and then also uh, putting carbon dioxide underground. So maybe if you can talk a bit first about why the permanence is relevant, and then these two different categories, explain to our listeners what the pros and cons and the challenges of these two categories are.
Sure. Well, the reason that permanence is relevant is if you care about kind of the really long term climate change and climate impacts extending out hundreds and hundreds of years, the only way to, in the long run, reduce the environmental change, the environmental harm from these historic emissions of carbon dioxide, the only way to do that is to permanently remove it. There's no other way. There are ways that we could temporarily reduce risks by adaptation or by sunlight reflection. But if you want to, in the long term, reduce the way that we've altered the Earth system, then you need to permanently remove carbon. In some sense, I think about it as building the time machine. So putting in all these emissions of coal, gas, oil, and cement, all this carbon dioxide and other greenhouse gases, that's changed the climate, and that climate change will go on a human timescale essentially forever. And that's true even if we cut emissions to zero. Emissions add to the problem, but cutting emissions to zero doesn't make the problem go away. The problem is these historical emissions, or it is one of the problems. And if one wants to deal with that, if our children or grandchildren want to deal with that, then permanent removal is all, the only way to deal with it in the long run. And as to the two, everybody divides these things up differently. There's buzzwords around nature-based solutions and a bunch of stuff that's very confusing. And because there's all these little companies involved, everybody's trying to spin their thing with some name or oversell. I think it's useful to think that there's only three fundamental ways we store carbon. One is the one I've already talked about, basically in what a chemist would call reduced carbon, biological material, cellulose, trees. The other one is as a stable base. So high school chemistry, carbon dioxide, when it dissolves in water, forms a weak acid. And acid plus bases make salts. And when carbon dioxide is reacted With a base, you have a stable salt, and that salt basically constitutes permanent carbon removal. That salt may be dissolved in the ocean or it may be a stable salt on land, but in either case, that's permanent carbon removal. So that's all these things called accelerated weathering are in that category. That's the second category. And the third category is you actually take carbon dioxide as a gas and put it deep underground, which it turns out industry actually knows how to do for other purposes pretty well. And that is another way to do permanent storage. And to get that carbon dioxide, you need to either take CO2 directly out of the atmosphere by an industrial process, that direct air capture, or you can burn biofuels and capture the CO2 from that and put it underground. That's called now biomass with carbon capture and storage, or BECCS. Both of those things have the end point of making compressed CO2 stored underground, whereas the accelerated weathering or geochemical things all have the endpoint of uh, carbon kind of stored as a stable salt, probably in the ocean.
Right, right. Okay. Okay, good. So we've set our table here very well. And I think the next question that's really relevant to this conversation is how much it costs to uh, do this now. So the various methods that we've just discussed, if you can give us a sense of how much does it cost to remove carbon in these different methods, which one is sort of the most expensive and which one is the least expensive, and then maybe put that cost in some framework, because I think it can be very hard for these numbers sort of in isolation to um, make much sense. Like how expensive something is, is relative. So what are they cost, and how expensive is that really right now?
So, lots of these costs are not clear. This is emerging industry, and many of these things are not being done at commercial scale. So, for example, one of the ones that I think is potentially the most important for the capacity to do large amounts of storage with relatively low environmental impact and relatively low costs is adding alkalinity to the open ocean. But nobody really knows what it costs because we haven't done the engineering analysis and science. I think it's extremely likely it's less than $1,000 a ton carbon. I think it's or a ton CO2. I think it's probably possible to do it around $100 a ton CO2 or less, but we just don't know that answer. And say for direct air capture, where of course I founded that company, I'm not involved anymore, and I've got friends who founded a bunch of the other companies, so I know that pretty well. Have a lot of inside information. I think as of right now, the contracts for actual direct air capture projects are sort of order $500 a ton, the actual cost of the early projects. But the big question is, what will the cost be after people have built a few million tons a year of actual capacity and begun to go down the early part of the learning curve, begun to actually shake these technologies out? And I think the honest truth is we don't know. I think it's possible that number is a few, $200 a ton carbon. I think getting it below 100 is really hard. But we just don't know these costs well because we don't. In general, there's no way to forecast costs accurately until you have a developed industry doing them. Um, put those costs in context. If you want to remove 1 billion tons a year, which would be sort of a 40th or so of current emissions, um, at $100 a ton, that's 100 billion a year, which might sound like a lot of money, but in context, the world's now spending almost $2 trillion a year on clean energy. So maybe another useful way to think about it is if in the long run, uh, people wanted to really take a lot of carbon dioxide out of the air, 1,000 gigatons of carbon dioxide, building the time machine going backwards, that could be achieved over a century for about 1% of the world's economy if costs were about $100 a ton, very round numbers. Whether people will want to do that or not, I have no idea. I can't say, but I think it's clear it's a thing that humans could do. 1% of the economy is something we could afford. And I think there are reason to believe, because there are several different technologies here, that we can get costs of some of them to kind of that $100 a ton area.
Yeah. And and that was in the when the Biden administration had launched a program, the carbon negative shot, and I think that was what their goal was aiming for that $100 per ton. Um, and so, do you have a sense of understanding that all of this is we don't know yet, that it's all still being understood, and which method is going to be the least expensive, or is it still
And so I think there's no way to know that, and I think that's not just the right question. This isn't just about lowest cost; it's about environmental impact. All these things will have environmental impacts, and it's about a bunch of regulatory barriers and how these things connect with the energy system. I guess my view is that if you're talking about things that could be really big, meaning many gigatons a year of carbon removal, that the things that seem most plausible are different kinds of accelerated weathering, either open ocean alkalinity or enhanced rock weathering, and those are very different, and we can talk about them, or direct air capture. Um, and those are probably the things that feel to me most plausibly could scale to that kind of scale with relatively low environmental impacts and costs that could be of this order.
Okay.
But I
Okay.
think the crucial thing to say is that that first of all, important to say, there are startup companies that will claim lower costs because when you're selling and trying to raise money, people will make all sorts of stuff up. So, in direct air capture, especially where I know lots, there's all these companies that claim to be able to make things at well under $100 a ton. I wish them well. I hope they're right, but I'm skeptical because I've seen lots of industrial costing, and when you're serious about actual capital amortization rates and the cost of simply building a contactor, simply building the shell that uses no energy and actually doesn't have any of the expensive equipment inside it, using the shell that moves enough air through it, that easily nets out to many tens of dollars, like $30 a ton CO2 and up. So I think this idea of getting really low is implausible. And that comes partly from people who sort of fantasize that, industrial innovative capitalism can like find some solution to this that doesn't need government mandates, but I think that's unlikely.
So that's a perfect segue to what I was going to ask next is how then do you think we should collectively, can we collectively, work on bringing these costs down? I mean, you have venture capital models. There was a fair amount of money the Biden administration had put towards developing some carbon capture technology and projects. Those are currently the current Trump administration may be pulling some of that money back. It's sort of that is happening in real time. So the role of government investing in these projects, what is your view on that? How much should the government be investing in developing these technologies, and do you have a sense of how much that's happening in other parts of the globe? As we just mentioned, it's sort of being negotiated in real time here in the United States.
So I think a couple kind of big picture things. One is, at least in my view, the goal for even the next decade or maybe closer to 20 years for carbon removal should not be to actually operationally remove a substantial amount of carbon, substantial in the scale of the kind of overall climate system. I think the sensible goal is really about learning. It's about learning which of these technologies are doable at an interesting cost with low environmental impact. Because, at least in my view, I don't think it really makes sense to deploy this really at scale, like kind of these gigatons a year numbers, until emissions are a long way down to zero. Not all the way to zero, but say emissions have been cut by two-thirds from where they are now. And I think, with some luck, we could get there early in the second half of the century. Things are going quite well in the emissions cutting world. But I think that's an important preconception. Not everybody agrees with that, but that's my view. And I think to learn what things cost, you can't just fund a bunch of academics to go study it because academics like to admire the problem and they like to use the most complicated high technology because that's typically what they get publications from. And so that isn't going to do it. And venture capital, little startups can be useful, but the problem is there's a mismatch between the way that startups get going here, which needs to exploit some little niche early on, and what are reasonable, informed experts and technologists would think are the scalable possibilities. So what we're seeing is a bunch of startups in this area that I think have basically no chance of producing something that is scalable and important because it's not their fault, because they're going after a niche that they think they can make money in the voluntary market now. And you've got to do that if you're trying to start a company. So I think the startup world is not it's helpful. There's a lot of stuff coming out, but it's not as helpful as it could be. So I see there being a real hole here. And I think, first of all, I think there's a real obvious environmental justification for kind of option value for learning about whether which ones of these carbon removal scenarios could really work at large scale, because we are building up this environmental problem of the CO2 in the atmosphere, and the option value of figuring out how to reduce it is big. You can actually make calculations of this in these kind of global models of economic choices under climate change, and the option values can easily be many trillions of dollars, not making that number up. The value to society of knowing more about these technologies is large, because it
Okay.
changes your strategy if you care about public policy. So I just want to make that argument. It's worth spending money. How much money? I think in context, so I'd perfectly be comfortable with kind of across the world spending a good $10 billion a year fundamentally on developing these technologies. How to do it is the challenge, because it's
And
easy to.
where's that money coming from? Is that governmental money?
So I said I'd be comfortable with that. It's not happening now. It's considerably less than that, and and it's coming from a range of sources, and those sources are complicated because, of course, government. One answer is government funds stuff directly. The other answer is government offers some kinds of incentives or regulations that cause money to be spent. Both of those can work. Long, complicated conversation beyond this scope about which is better. But I do want to come to one, I think, really important thing, which is there's an assumption, widely shared assumption here, that this has to happen in some kind of market mechanism. And I think that this assumption is driven by the fact that a bunch of these early startups, including the one that I founded, have been tied together with voluntary carbon markets. My personal guess is these voluntary markets will not end up being having really any role in the long run. They may play a useful role in lubricating things at the beginning, but in some kind of basic way of the way we should regulate capitalism. Companies shouldn't be doing a bunch of stuff that costs money that doesn't return shareholder value. And there's no question that if there's some real social value to doing removal, then the answer is you need some government structure to do that. I feel like that's kind of the basics of what an environmental economist would call an environmental externality. So the question is how to do it. So one answer is these voluntary things. I don't think they're that useful. Another answer is government kind of essentially pays for carbon removal at the marginal price for reducing carbon emissions. That's another way you could imagine doing it. In the very long run, I think for a bunch of these things, the right answer is that government procures this service in much the same way as government procures, say, sewer services.
Mm.
And I think the key thing there is it doesn't do it on a kind of dollars per ton basis. The government's procuring a public service, but when they do it well, and the US government actually doesn't do this very well, that's why infrastructure is so expensive, you can still have all the benefits of super competitive capitalism in the supply chain to build the sewers. But the point is that you don't need a market clearing to do that in the end. The actually asking for, say, a certain amount of alkalinity to be put in the open ocean, governments can have contracts to do that without paying people on a dollars per ton basis. And I think that's kind of, as I see them, packing a lot in here, key to having this work in the long run.
That's so interesting, the sewer analogy. And so, if we were to talk about this like in 2050, imagine there being sort of this sewer system for carbon dioxide. Um, just because I think it's something that many people, myself included. What can you help us envision that? What does that look like?
I think that the key points are that for many of these technologies, you need all the power of kind of focused hard work that happens at a startup and capitalism to make things cheaper. But these things also have environmental harms. And for some of them, it's very hard to measure how well they're working. Particularly, maybe enhanced rock weathering is a really important example of that. And I think we know that we don't do a good job when those things are linked together in one entity, because one entity inevitably will oversell how well things are working and undersell the environmental harms. So that's why I don't think we want a market in the long run that just pays people dollars per ton for something where they then have a big incentive to exaggerate the tons or undersell the environmental harms. That's why I think we want independent agencies, either not for profits or governments, that are doing the science and assessment to understand what's being done and what its consequences are. And then we want strong competition to actually get this immense amount of materials moved around to remove the carbon. And that's why I think we need markets that look quite different from the way we're thinking about it now, that can address this problem using the benefits of kind of focused, innovative capitalism without having the kind of trap of companies overselling and overclaiming about environmental impacts or removal amounts.
This definitely depends on a strong, robust regulatory framework.
I think that's essentially axiomatic. The cost, I mean, carbon dioxide, nobody gets a direct benefit from removing carbon from the atmosphere. It's a definition of a public good. There's no version of the world where we manage public goods like that without some government force. Government force can be done in very efficient ways that allow the markets underlying them to work efficiently, or government force can be done in really inefficient, stupid ways. And obviously, I'd prefer the efficient ways, but I don't think there's a way we solve public goods problems like climate carbon emissions or removing carbon without some role for government. That's precisely what government's role should be in kind of Econ 101.
So we're getting towards the end of this conversation. I mean, there's so many questions here. This is just I feel like we've just tipped, tip of the iceberg, as the cliche goes. But last thing I just want to ask before we wrap up, because it is currently there's a lot of involvement in the oil and gas industry in this sector. What is your view on how and whether the oil and gas sector should be involved in the growth of this sector?
I'm not worried about it. I know a bunch of other sort of fellow environmentalists are, but I think you got to focus on the flows of power. The reason that the oil and gas industry is doing this is not because they kind of woke up feeling green. The reason is because of incentives and rules that governments have established that are starting to penalize using the atmosphere as a waste dump for our carbon. And those rules and incentives didn't just come because the government woke up feeling green. It came from the power of the environmental advocacy community pushing. And so I think it's driven by and should be driven by environmental advocacy in the long run. But when you ask who can actually execute these things, I think for some of the particular technologies, you need the kind of uh, chemical engineering and execution skills, some of which are in the oil and gas industry, though actually more technically correct. They're really in the engineering and procurement and construction firms that work with that industry. That really is kind of where those core skills are. The industry is more an integrator. And so I think if environmental pressure is driving that to happen, that's a good thing. Obviously, it's also true that some companies will try and use this in a kind of greenwashing sense, over claiming about what they're doing to avoid regulation. And obviously, I think that's a terrible thing. But I think you've got to distinguish that problem, which is real, from the fact that I've got no problem that if government and environmental advocacy has driven incentives that are driving some parts of the industry to kind of, if you like, turn swords into plowshares, I think we should celebrate that.
Well, listen, I mean, this is such an interesting topic. I love the idea of the sewer system for carbon removal is just so interesting to me, and thinking about that in the future really helps sort of bring a different perspective to this conversation. So, David, we're sort of running out of time here, but I just want to thank you so much for having this conversation. Really appreciate it, enjoyed it, and thanks to you, SOSV.
Thank you.